Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna do some teardown of basically two heaters, so to say. Now this is just to give a rough idea and overview. So this is what we call blower heaters, so to say. These are very cheap, low cost, effective, and you can buy them for surprisingly cheap prices. So they're rather simple structure, nothing too fancy or too complicated. And then you have its replacement. Because these have naked nichrome wire, people do not like to run them because it smells, because it's reacting with the stuff that is in the air, including oxygen. And not to mention, these things are very weird. Basically, you can buy 10 of these, some will last forever and some will poop itself in 1 week. So they're okay for what they are, but not very robust and definitely not pleasant. So to solve that issue, this puppy was created. You must have seen this sort of system recently. We call this PTC. Now this is positive temperature coefficient. So the idea is same heating element as in nichrome wire or something similar is encapsulated in some sort of ceramic cement or refractory cement, and the idea is it forces the wire temperature to be much higher, and benefit of that is the resistance goes down drastically. So in this sort of system, even though you are blowing air and it's getting the same, let's say 1.5 kilowatt of power, because it's air cooled and it's able to dump its heat, the wire itself does not get too hot. So in case the blower motor fails here and the air stops blowing, the coil will keep drawing power in the same 1.5 kilowatt, which could become a fire hazard. Now, of course, we do add a lot of safety into this, but that is the inherent, as in like the element itself is fragile in that regard, as in it will cook itself. However, whenever you are talking about PTC, because it's encapsulated, the moment airflow stops, this also has a fan, the moment airflow stops, kaput. The resistance rises exponentially. That's what it means. Positive temperature coefficient. Resistance rises and then it reaches a lower steady state. So keep the resistance stable enough. So power draw will start to go down. So element itself has a very good what you call self-regulating features, and that's why you will keep hearing people say these things as in like they are more efficient. Again, heaters are 100% efficient. Heck, I'm running basically a heat pump here right on top of me, and that is more than 100%, so it is doable. So what does this mean? Efficient? It simply means if you are using this to heat something, it will not increase the temperature beyond its own resistance limitation. Meaning, if you design the system right, and let's say it's an object that you're supposed to heat up to 70 degrees Celsius, you will tune everything that is for that resistance. The moment it goes above that, it will start to cool down, because resistance goes up, current draw goes down, it reaches an equilibrium. So it does not have the overheating issue. That's what this means to be more efficient. So, but again, heater 100% efficient, you can't do much about it, but you can improve the coupling, meaning I do not want a boiling room. As long as it's not cold, me cool, me fine. So let's dive deep into it. In my Hindi stream, I did the basically tear down and all that, so it will be a bit smoother this time. Okay, so there are 4 screws in this, and this design is surprisingly common. I've seen way too many companies manufacturing it, although I'm genuinely shocked how the heck this happened, that power appliance that is this heavy started to come with something like this. So I have no I hope it captures it. So I have no idea why it came with a basically plastic grounding pin. You have to understand that India generally has 2 of these plugs. One is a small one is big one, like this. One is 6 amp, this is 16 amp. The idea with that is that if you have a proper wiring, only then you will have socket for this. And while the small one can handle that kind of power, you do not know what's the wiring behind it. So having a different plug is like, the electrician should do their job and it should have the wiring that can sustain it. So that's why we use thicker wire, even though you can draw the same amount of power from that, but it would be unknown. So companies do use this sort of plug for heavy loads like a heater, which again, heater in certain scenarios can run at full load 24/7 into 365. So let's dive deep into it. It does not have earthing, and again, it's a double insulated. You must have seen all your mobile chargers have 2 squares. That's why they also don't have earthing. So, ta-da! As you can see, there's the blower motor and there's the heating system. Now, this blower motor is AC shaded pole motor. Now, I always seen the older block C design. I've seen that in microwave, but this is the first time I've seen the simpler design. They do have very high RPM. I was kind of shocked. The RPM on this puppy is fast. So this does spin fast. Now benefit, if it jams, let's just say the blower motor gets jammed, the current draw will not increase. That's the benefit of shaded pole motor. It has fixed loading, meaning it's not like a induction motor where if you jam the rotor, the inrush current goes up stupid, meaning it has like locked rotor current which is much higher. This does not have that. So it's a very low cost, very cost effective, but again there is no speed control into this, and I'm not that happy with the sound, so to say. So we have this heated grill that is on front, simply because again, no matter what kind of plastic you use, if you expose it to very long duration heat, it will start to like, you know, wear down. So this is for the front end, and while you may be seeing structure, this structure, these are made out of mica sheet, and this is nichrome wire, naked nichrome wire. Now because nichrome wire is exposed, it's random, meaning if it is perfectly like, you know, not oxidizing, it will last forever. If it's oxidizing, kaput. Now it has two basically thermal limit switches. So those are the first line, I would say second line of defense. If any of the coil starts to expand too much, touch this or this, that's why it's on both sides, it will cut the power. Cool, awesome. And then there is this tiny fuse here that is a last line of defense, meaning if that puppy reaches 120 degrees Celsius, kaput, and that cannot be reset. This will reset, this will reset, and there is a thermistor here that will reset, but that will not. That's the last line of defense. So what they have designed is and this is a kind of clever switch mechanism. You have off, then you turn on. The first thing it turns on is the fan. So air already starts to blow on the coil, which again, if it's in a cold room, it is already cold air. Then you turn on the first coil, meaning even though it looks like it's a one unit, there are two coils, so to say. So one coil is 750 watt give or take, and second is same, and overall it gives you like around 1500 watts. Benefit of that is now you can easily, the fan was already on, then you started to heat the element, so that's a very good way of increasing the lifespan of the coil. And then you have one coil, two coil, and this thermostat, this actually allows you to do regulation. This is a not regulation, this is power, as in like 750 or 1500. This is temperature based system. So on the other side you might see it smallly, it may be visible. It's a thermostat that based on the temperature, and it's again, it's a bimetal strip, and you crank on it. So based on the crank input, it gives you like how quickly it turns it on and off. It's basically PWM, but it's slow PWM. It's not like, you know, 10 times a second. It's more like, you know, 5 or 2 switching event per hour. It's supposed to be slow. It's not designed to go tuck, 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 tuck. It's supposed to be slow, and it does work, but it is sloppy. That's why like you can't, you don't see any reading on them. It's like, okay, 50 degrees Celsius, 60 degrees Celsius. There's no point. It's sloppy. So this sort of system is surprisingly cheap, does work, and but again, randomness is a big issue, that you could have a scenario that's like lasted forever or something that kaputted itself, but it can be made by yourself if you want to. If you really want to, like, mica sheets are surprisingly low cost, especially if you look into microwave suppliers. They have all of these things. Shaded pole motor, that's also not that difficult. And again, this shaded pole motor, the only weakness it has is the bearings. So as long as the bearing is fine, and be mindful, because these are low cost, they don't have bearing, they have bushings. So if you are in a clean room environment, it's gonna last forever. If you are in dirty environment, you know, open it up, clean it once in a while, or oil it, it will last forever. So that is there. So this is a surprise. Oh, I forgot to put this puppy in. Although it does not have earthing, that did confuse me. This is metal. It could, again, unlikely, but it could touch the nichrome wire, so it could get energized. So unlikely. I'm not gonna say it's very likely. And again, it did went to India's testing, which is ISI testing. So I am hopeful that they did their part right. If not, well, what can we do about it anymore? So yep, let's now plonk this puppy in. Yep, it seems fine. Okay. Okay. Am I pinching some wire? I do hate this part, like the modern equipments, appliances are not even designed to be opened up or something like that. It's like, yeah, figure it out. I remember old devices, they used to have like, wire loom, so you can open it up like this properly. It's such a tragedy that we get such poo-poo equipment just to save few cents. Okay. Yep, this is done. So now let's open this puppy up. Now this is again same wattage rating, 100 and basically 750 and 1500. Although it does not have a thermistor, it has two knobs, but one knob is basically the same thing. Turn on the fan first, then you have 750 and then 1500. Cool, awesome. This one is swing, so you can see it will go swivel like this. It swivels. It does not have thermistor, so if you want it to run at, like, let's just say 450 watt or reduce the time, it's not gonna work. The only good thing about this is that if, let's just say worst case scenario, the fan jams, which again, fan is a moving component, it will go down, especially if you have pets or something like that. The heating element will start to heat up too much, resistance will start to go down, so it will self-throttle. And be mindful, it also has a lot of thermal cutout and this and that to make sure before that ever comes into the play, it still would be safe. Or if those mechanisms fail, it will still be safe. So it does not have that. And this gave me such a bad vibe. It almost feels like that engineer only got 5 minutes. It's like the product manager is like, make me the heater. Cool, sir, cool. How much time? No, in 6th minute we have a injection mold design. It's like, who puts the power switch here? Like, the light is here. Light should always be on top so you can see from both sides whether it's on or not. Like, there's so many, and again, it is supposed to be handle here. It's like, what the hell is this? My hand is not that big. This is not a handle. So many choices in this pissed me off. That's why actually I'm tearing it down. It's like, it pissed me off. It's like, what the hell is this? Oh, and to give you, like, a salt on the wound, the idea is fan, again, it sucks in there. So what if you had a filter? So they have a filter, right? It shows in the manual that you have a filter, you're supposed to open it and clean it. Cool, awesome. This is the filter. And if you're like, wait a minute, it matches the exact same physical print there. Yeah, it's useless. It's literally useless. It's worse than what my computer has. I'm pretty sure the engineer would have designed it and they're like, no, let's save 5 rupees or something like that. So this is just plastic e-waste. Like, there is no reason for this. Nothing. Like, nothing. That's why I can guarantee you an engineer will design better than this. It's just that I'm pretty sure they were like, 5 minutes, go. Like, the power switch is here. Like, it should be on top. Oh, by the way, if I wanted to, reduce component count, make it more cheaper, moving the power switch and make sure that power switch has inbuilt light, that would have been double duty. So power switch is on, cool, the light turns on. Because be mindful, these also act as a switch, so you do want a master switch. This is just like, bad. It's almost like prioritized, just getting it done and like making it cool and all that. It's like, if they have photo of this being handled, I'm like, bro, this is not a handle, this is abomination. So let's open it up. Okay. I've already removed the screws, so okay. And here's the, so you have the LED there. I'm not sure whether it's a LED or neon, but okay. So we have this mold, plastic mold, and this is the main star of the show. These white units that you are seeing, these units are what we call basically the actual element. The radiator is just there to leach heat away. They are becoming a very crucial thing because of electric vehicle. In engine, you just circulate the engine water into the cabin and voila, you have infinite heat at that point in time, as long as you have fuel. When electric vehicle, they needed something that can randomly wrap it up. Although they are falling out of favor because it's like, hey, you already have a AC compressor unit there. You already have most of the component of a heat pump. All you have to add is like a reversing valve or something like that. Or heck, don't even have reversing valve, have the refrigerant running in a fixed loop, just have liquid that is switches. So that way, because again, you do not want to deal with refrigerant, you want to optimize the path. So it always works the same way. It's just that Coolant goes in one direction, coolant goes in another direction. Tada! So the hot side can go into the cabin or into the outside radiator. So that's why like these are not as popular, and it almost looks like designed for EV, but I'm a bit confused. It's like either it's overpowered, as in, because EVs generally have 400 volt, 800 volt, that sort of power, and I'm pretty sure this will not work at 12 volt. It's like this is designed for 220 mains, so I'm pretty sure it was used somewhere in 400, and again it would have a big ass blower motor. Like this has a tiny 12 volt motor, and again, as you can see, I'm pretty sure you can see here there is a switching converter. That is odd. I have seen certain designs which uses the same thing, like a PTC element, but they have a shaded pole motor. I will trust those, because here you have two components that can fail. First the SMPS, then you have the 12 volt fan, and that's the reason why I hated this system so much. Everything else is like, okay, you know, little bit of this, little bit of that. Maybe injection molding was like a bit difficult. Wiring could have been a bit messier if you had everything on top, which again I doubt it. But okay, cool. Why the heck it has freaking 80 millimeter fan, man? Like, it does not have this. And be mindful, it fits inside. What the hell? Like, it makes too much noise, which again, given how expensive it is compared to this sort of system. This sort of system I can't blame, because this is dirt cheap, and everything is designed to be like, you know, buy and forget. And heck, all I would have wanted, some things like this, just those coil be embedded into ceramic, nothing more. Heck, I should make that. So this has like a same heating element, and here you can see what we call AC synchronous motor. And yes, it's a AC synchronous motor. It has magnets inside that rotates at very high RPM. Then there is a lot of gears. So that puppy has a lot of gear, and then it swings this back and forth, back and forth. So that's a AC motor, which again, it's logical. You do not want AC to DC converter in your equipment. This has it, but for that main fan, which again goes like, oh, and that's why like I personally hated this. Even if you put the fan on top of it, the spacing would have like actually match up. And again, all you would have needed, if like, no, we wanted like perfect flow, which again, this area of any fan is not airflow. This area of any fan is not airflow. So generally you do scoop 'em like architecture. Basically you scoop it up. So they could have easily had like 120, a scoop, a little bit of scoop, not too much, just a little bit of scoop. And that would have force fed enough air at quieter noise. Oh. This also has a thermal switch. That's a resettable. That's why there is two of them. You can see a tiny capsule. I hope you can see a tiny capsule there. That's a last line of defense. If that goes, that's permanently bricks the device. That thermal switch that opens and closes, and it's also on the mica sheet. Although here is the ironic part. This actually, the nichrome wire itself heats up too much, but this radiator does not, and that's why it can be encapsulated in plastic compared to this one where everything was encapsulated in mica. And you can see it also has wiring where you select the selector switch from here, generally selects either only one coil is active or both coils are active. That's what you have. And again, this also has the same logic. The fan must be turned on before you start heating these things up. Just again, like I was genuinely I wanted this to be good, but again, since I'm trying to develop my own product, I'm like more aware of these sort of things. Although I have to say, this was very clever. It does not have too many linkages. It's very simple. It's just a crank that goes like this. Twing. It's like it goes in one direction. This goes back and forth, back and forth. Very clever. Like, I have to say, it was very clever. It also has earthing, but earthing does not bound to anything, not to this metal or even to this grill metal. It's like, okay. Indian government is allowing basically any sort of electrical insulation or anything. It's like whatever goes. We have wire nuts and all that. It's like, okay. But again, design wise, I have to say, like it only would have required 7 or 8 minutes. The engineer could have been like, okay, I got this. This is the first pass. Let's switch the button from here to here, have that LED there. And again, this also has that risk. If you open it up, there's a very good chance you're gonna tear that part apart. Very good chance. So, and again, I've seen certain designs that also use AC shaded pole on this, which again, far better design. If you want like something just buy and forget, because I can guarantee this heating element will last longer than the SMPS and the 80 mm fan. So this almost pissed me off enough where I was like, should I redesign this? Like, should I really put effort into it to, like, have a metal enclosure? Because again, I'll show you guys. So again, your boy has experience with fume extractor. So again, I'm used to, this is stainless steel, and this is bent by hand. That's why the joints are not very tight. Now the final pieces that we are making is made of basically pressure metal. So, sorry, mechanized bending machine. So it's a very crisp, tight, and it works. So I was thinking, like, should I make something like this? With this, I'll have 120 millimeter fan and have much lower noise. Like, can you imagine? Like, they would have been really awesome. Like, this works cheap, but smells and noisy. This does not smell and quiet, but no. And again, 80 millimeter fans are hard to find. So, that was weird. Like, that's the only thing I have to say that was weird. Like, they have enough brain. It's like, hey, don't put a 12 volt everywhere. It's like, okay, this is AC main. So why don't have the same thing? Why? If you know the answer, please do tell me. Like, why would somebody design something like this? The only answer I can come up with is that they wanted this form factor, because all the other system, even though heating coil could be the same, while shaded pole motor is not that small. So that's the only explanation I could have. Or unless somebody manufactures this sort of motor but at higher RPM. These are generally very, what we call turntable motors. They are generally used in microwave plates. They are very high torque. They are like torquey puppies, but they don't like, I've not seen them used for fans. So this was the interesting teardown that I wanted to share with you guys. So again, comment, do you think I should try to encapsulate this system into something like this, like, stainless steel box where I can like trust it? Again, I'll make sure it has proper earthing, but that was it. Again, this was like just abomination. It's like, what were you thinking? Like, I can guarantee it. Engineer designed this with a, like, air filter, but like, they're like, nah. Anyway, so this was my small presentation on basically teardowns of this sort of heating elements that you have, room air heaters. I would urge you, like, if you can afford it, please go for PTC. It smells nice, as in like it does not stink. So that is there. Although do try to find that has a quieter noise. Make sure, like, I'm not happy with 80 millimeter fan. So this was my presentation on basically teardown of fans and room heaters. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.